Don't forget to subscribe and ring that bell.
And here we are, back with the 2024 free response question 4 AP Calculus AB exam. I'm still running on this high here. Still running on fumes, people. Let's get going. We don't get a calculator. Oh, poop. But we'll be okay. Let's go. Woo-hoo-hoo-hoo-hoo. Graphs, tables, and charts. Y'all know how I feel about them already. Number 4 reads, the graph of the differentiable function f shown for x between -6 and 7 inclusive has a horizontal tangent at x equals -2. Right here. And is linear from 0 to 7 on the x values. Here, straight down to here. It is a straight line. Slope doesn't change. Let R be the region in the second quadrant bounded by the graph of f, the vertical line x equals -6, and the x and y axis. Region R has an area of 12. Okay. The function g is defined by g of x is the integral from 0 to x of f of t dt. Find the values of g of -6, g of 4, and g of 6. All right. Let's start this. Let's start with g of -6. All right. If I want to find g of -6, I am just throwing a -6 in for my x. So I'm going to integrate from 0 to -6, right? F of t dt. Right now, I should know that my bounds, the smaller values on top and the bigger values on the bottom, I can switch those, okay? But I have to negate my integral when I switch them. And all this is asking for me is the area under the curve. Remember, the integration of a graph is the area under the curve. So from -6 to 0. That's the region R. They gave us that already. That's 12. That's easy. But what you can't forget to do is this is negative because we had to flip our bounds. So I'm going to say -12. And that's g of -6. Now I need to do this for 2 more values, if you can believe it. Okay, let's start on the next one, g of 4. Again, I'm just throwing a 4 in for where my x was. And again, it's just area under the curve from 0 to 4. Okay, so if I look up here, I have, oh, let's get rid of some of this. We know, okay, this is a straight line, this green line. So from 0 to 4, that's just a triangle, kids. It's a height of 2 and a base of 4. It's 1/2 base times height. That should be 4. All right, so we actually have our answer there. 2 of them are done. Let's go this purple. G of 6. So now I'm going to do the same thing, the integral from 0 to 6, f of t dt. Now I'm going to go back up here. And now I'm going to go from 0 to 6. Okay, keep in mind I have 2 triangles now. This one is 4. We already did that. But what's this triangle down here? This is a base of 2 and a height of 1. So it's 1/2 2 times 1. That is 1. Don't forget, this area is negative because it's below the x-axis. Anything below the x-axis should be negative. Anything above the x-axis should be positive. All right? So I technically have a +4 and a -1. There you go. 4a wasn't that bad, especially since we weren't taking the first derivative and second derivative. These all dealt with the original function g. Okay, 4b, for the function g defined in part A, okay, so I'm just going to quickly write that down. G of x was just the integration from 0 to x of f of t dt. All right? This is what they're talking about when they say the original function from part A. Okay? Find all values of x from 0 to 6 inclusive, at which the graph of g has a critical point. Okay, well, a critical point, that's where my first derivative equals 0. All right? So first thing is, I've got to find the first derivative of g of x. Okay? If I'm going to take the derivative of g, that's g prime of x, I also got to take the derivative of this side. And the great thing about this is derivatives and integrals cancel. And when the integral goes bye-bye, so does the dummy variable. And what's up here, my x, just goes in for my t. So my derivative of g is the graph of f. It's just the function f, which is what we have. And I want to figure out, where is f equal to 0? Remember, when they do this, it's a coordinate. Okay, what x value, that's a question mark, kids, makes my y 0? So I'm looking for the x-intercept, and that happens right here. When x is 4, my y is 0. So that happens at x equals 4. And it says, give a reason for your answer. I mean, I don't know. You know, I kind of like to write unnecessarily. Well, I really don't like to write unnecessarily. Let me take that back. I don't. So I'm going to say there's a critical point at x equals 4 since g prime of x, which equals f of x, is 0. I guess, you know, reason, I mean, I have that here, but now I've got it written out. And, I mean, if you want to mention that it's an x-intercept or whatever, that's fine. But, I mean, that's your reason. That's where f of x is 0, because f of x is g prime of x. And that's where g has a critical point. So I might want to say g of x has a critical point at x equals 4. Since g prime of x equals f of x is 0. It's all good. The important part is we know the math. The explanation can be done one of 1,000 different ways. This is nice. There is only an A, B, and C here. Okay. All right. Oh, look at, I spoke too soon. Now we're going to have a regular H, an H prime, and an H double prime. All right. Anyways, this is the last part of problem 4. 4C reads, the function h is defined by h of x equals the integration from -6 to x of f prime of t dt. So find the values of h of 6, h prime of 6, and h double prime of 6, and show the work that leads to your answers. All right, let's first start with h of 6. Okay, all I'm going to do is I'm going to throw an 6 in for my x. So it's the integral from -6 to 6 of f prime of t dt. Guys, I mentioned the following, that when I take an integral from any bounds of a derivative, that goes back to the original function from the upper bound minus the lower bound. I mentioned this in review, and I said it would happen definitely in the exam. It was on problem 1, free response question 1. I believe it happened again in free response question 2, and it's happening again right here. What do I mean? If I integrate f prime, that gives me f from the upper bound, 6, minus the lower bound, -6. All I'm going to have to do is figure out what y values when x is 6 and x is negative 6 and subtract them, literally. Okay, so let's go back up to our graph and see where f of 6 is. Okay, they give us that. Look at us. When x is 6, y is negative 1. Here's that point. So negative 1 minus, what about negative 6? They give us that too. When x is negative 6, y is 1/2 minus 0.5. That'll be negative 1.5. Okay, so that was an easy start, but we still got to do h prime and h double prime. So let's get here. All right, blue. H prime of 6. All right. Now, in order to find h prime of x, we need to take the derivative of h, which is the integral from negative 6 to x of f prime of t dt. Okay. Again, when I take the derivative of an integral, bye-bye, dummy variable bye-bye, this x goes in here, and it's f prime of x. I want that at an x value of 6. So f prime of 6, oops, 6. Okay, f prime is the slope of f. So I just want the slope of f when x is 6. Let's go up here. It's 6 right here. So I basically just want the slope of this line. Okay, I can take 2 points and do a change in y over change in x, or I can see, okay, if I go down 2, I go over 4, which is negative 1/2. And that's my answer. You could have done change in y over change in x. I mean, you would have gotten the same answer. Okay, would have gotten the same answer. All right, last but not least, purple. No, green. Let's go green, kids. The second derivative of h. First of all, we know the first derivative of h is the first derivative of f. So the second derivative of h is the second derivative of x. Okay, and I want that, again, at x equals 6. All right, now, let me explain this right here, right now. Okay, this is not the slope of f. This is the concavity or curvature of f. Okay, if I look where x equals 6, okay, I'm going right back up here in the graph. Let me get some, clear some space in our heads here. Right here. Boop. There is no curvature. This is a constant slope. It does not curve. If my slope, okay, let me explain it this way. That's why my answer is going to be 0. That means, let's not do that. That means it's going to equal 0. Okay, it's going to be 0. If you want another way to think about it, if the slope is constant, right? Didn't we just figure out the slope of f? If f prime of 6 is negative 1/2, what's the derivative of that? Well, the derivative of any constant is 0. Okay, so there's multiple ways you can do it, but that's the answer. It doesn't ask you to explain. Okay, it doesn't ask you to explain. Just show the work that leads to your answer. I mean, if you want to say there's no curvature at x equals 6, so the second derivative of h is 0, because the second derivative is the second derivative of f. Or you can say that the derivative of a constant, f prime is a constant, the derivative of a constant is 0. So there's multiple ways, but we are done for A, for B, and for C. And we didn't even hit 15 minutes, kids. This was a blessing to take this test. I'll see you for free response question number 5.
Don't forget to subscribe and ring that bell.